Hello, I'm Alex, and I'm a principal engineer in FT Group Products. Today, I'd like to talk a little bit about what we, as people who work on building digital products in 2020, can learn about interaction design and software quality from Super Metroid, a game released 26 years ago by a team of 17 people. The team was called Force, and they're still considered legendary in the gaming industry today. Nintendo, the publisher, was so confident about the quality of their games that they gave each box a stamp of approval. Its overall experience, while a little dated, still holds up. We've passed through many design and process trends since then, but can we really say that the products we built 5 or 10 years ago still stand up today? For those of you who aren't familiar, Super Metroid is a game where the player explores an alien world to try and stop a group called Space Pirates from developing bioweaponry. Sound convoluted? Well, it is, but it's how the story is told that I wanted to touch on. When starting a new game, you're presented with a monologue, setting context by recounting the events leading up to the start of the game. You play as a bounty hunter named Samus Aran, who has foiled earlier attempts at developing these weapons, and have received a distress signal from a scientific research station named Ceres. Ceres Station is deserted, not a single person in sight. The game encourages you to progress along a very linear path, starting in a vertical shaft, and along the way, you jump onto steps, encounter doors which you must shoot open. As you progress, you notice that you're filling out a map, and you might be asking yourself, where did all the scientists go? Then you encounter a room and find a few bodies on the floor. Well, that answers that. The next room is a dead end, but it contains the dangerous specimen you wanted to find. You attempt to recover it. What happens next is that Ridley, no, not our CTO, but the leader of the Space Pirates, reveals himself, attacking you. You get a few defensive blasts in, but ultimately in vain. He escapes from the station, triggering the self-destruct sequence of the station. The game signposts this, presenting a timer, and you're encouraged to run back to your ship. With the station tilting and the game prompting trickier jumps over pressurized steam and onto platforms. Within a minute or two, you make it back to your ship, safe and now in pursuit of the stolen specimen. Now, I really want to talk about the rest of the game, but this is a lightning talk, and I have a tendency to ramble. Hemingway taught us that many words distract the message, and Super Metroid takes this all the way. The monologue at the start is the only text in the game. The mechanics and the story are told exclusively through environment and gameplay. The design of Ceres Station is excellent because, as well as telling you a story of a Deep Space Nine style invasion gone wrong, it also gives you the real mission of the game, which is to recover the now stolen specimen. And it serves as a tutorial for the basic mechanics. It's not very challenging, but you now know how to walk, run, jump, read a map, and shoot to open doors. It's a tutorial without words. Nudge theory, popularized in 1995 and crystallized in the famous book in 2008, talks a lot about encouraging people to learn new behaviors by showing them the way, without explicitly telling them anything, but instead trying to give them positive feedback. At no point did anyone tell you to try and jump. You encountered a series of platforms, tried it out, and made some progress. The gameplay mechanics and level design are the two areas where Force spent the majority of their time, and even today, 26 years on, a dedicated community are learning new things. Some time ago, one of the original team revealed in an interview that he'd hidden an Easter egg, a love note, in one of the rooms, something that no one had found. So, from the opening sequence of the game, what can we learn? Well, firstly, it's entirely possible to gradually reveal functionality to users without needing to walk them through it. One of the key questions we ask in product discovery is about usability. Will the user understand a feature? And we have a fantastic example in the form of the knowledge widget on the left-hand side of articles on ft.com. It's unobtrusive and to a casual reader, quite quick to understand. Nudge theory suggests that positive reinforcement will teach people new things, and perhaps we can go a long way by exploring less in our face onboarding techniques. For example, an animation like Facebook's like button revamp. Another thing which worked so well that you don't even notice it, it has almost no bugs, at least not in ways that disrupt gameplay. That's very much by design. The team knew that no software can be perfect, and they wanted to make sure that the basics worked flawlessly. These games were both digital and physical, being baked onto cartridges, meaning that the low batch size principle of lean manufacturing couldn't really apply. Atari nearly killed the gaming industry in 1983, with ET being famously committed to landfill because it was genuinely unplayable and didn't sell. Electronic Arts have done a fantastic job at resurrecting Atari's ethos, and today constant patches and DLC to even get a functioning product are sadly common. I'm not saying that we should slow down and implement heavy QA, but there is a lesson in EA's extreme of seemingly skipping it entirely. Nintendo's quality process is a closely guarded secret, even today, but we do know that it found its roots in a system called total quality management, in which every person in the team is committed to quality throughout the process, instead of leaving it to someone else at the end. An unfortunate reality of game production is that there's a lot to do and not much time to do it in. And so leaving time at the end will only result in delays and possibly even having to wait years until a new console is released. What can we learn? Well, we can prioritize our efforts and try to ensure that the core user experiences are fluid and interactive, fluid and intuitive. Just like jumping in Metroid, making trade-offs in the low-impact areas, ensuring graceful degradation, and investing in support and observability tooling so that we know when something has gone wrong. What happens when JavaScript fails? Or what if a database goes down? And what about that CSS fallback that only kind of works if you're in a browser that isn't Google Chrome? Coming back to the user and discovery, if we look at customer value, will the user choose to use our product? Well, if even the basics are buggy, would you? These two takeaways are something that all of us, just like that team of 17 in 1994, without realizing it, own. With the advantages that continuous delivery and learning give us, let's build products that last. Thanks for listening.